In the early 1970s, the industry believed the L-1011 TriStar had rewritten the rules of safety. Triple redundant computers, one of the first true auto-land systems, direct lift control for precise approaches, and an engineering approach designed to manage failures safely and predictably. It was a wide body built to handle demanding conditions and minimize the risks of operational errors, and, on paper, couldn't be brought down by the mistakes that plagued the DC-10 and even the early 747. Yet the record tells a different story. Despite the technology, despite the systems, despite the reputation, the TriStar's history is marked by moments where human error, weather, structural limits, and rare technical failures broke through the layers of protection Lockheed built around it. Not many accidents, but each one significant enough to show that no matter how advanced an aircraft is, there are limits technology cannot overcome. In this video, we'll be exploring all the accidents of the L-1011 TriStar, from the first warning signs to the events that defined its operational history. On December 29, 1972, the Lockheed L-1011 was still brand new to the world. Eastern Airlines had taken delivery of its early TriStars that year, and the model was billed as the next step in wide-body safety and automation. One of those early machines, N310EA, flight number Eastern 401, left John F. Kennedy Airport at 2120 EST for Miami, with 163 passengers and 13 crew aboard. Captain Robert Albin, a 32-year Eastern veteran, commanded the flight. First Officer Albert Stockstill and Flight Engineer Donald Repo made up the cockpit team. The L-1011 on that night was the type's first real test in everyday airline operations. The approach to Miami on that clear night began routinely. After lowering the landing gear, First Officer Stockstill noticed the nose gear locked down green indicator light had not illuminated. The crew cycled the gear and repeated cockpit checks without resolving the indication. Flight Engineer Repo left the cockpit and peered into the forward avionics bay through an access panel to visually verify the nose gear position. An off-duty Eastern maintenance technician, Angelo Donadeo, also came into the cabin and assisted. While the crew concentrated on the light, the autopilot, which had been engaged, was inadvertently disconnected when the yoke was bumped during the checks. The crew's attention remained on the gear problem and the missing light, and the airplane began an imperceptible descent. The key sequence is tightly documented in the National Transportation Safety Board's accident report. 50 seconds after the L-1011 reached its assigned holding altitude, the captain instructed the first officer to engage the autopilot. Soon after, Repo left the flight deck to inspect the indicator light. While Repo was below the cockpit looking through the access panel, the aircraft slowly lost altitude. The flight crew did not notice the change because their attention was off flight instruments and focused on the landing gear indication. At 2342 EST, the TriStar struck the Miami-Dade County Everglades about 18 miles west-northwest of Miami International Airport. The human toll was high. 101 people died. That number comprises 3 cockpit crew, 2 flight attendants, and 96 passengers, and 75 survived, many with serious injuries. The crash was the first fatal hull loss of a Lockheed L-1011 and the first major crash of any wide-body transport. Lockheed's L-1011 TriStar began as an ambitious attempt to leap ahead of the late 1960s wide-body field. Contract awards and detailed design work ran through 1966 to 1970, with the first flight on 16 November 1970 and entry into revenue service in 1972. Lockheed pitched the TriStar as a quieter, more automated, and more passenger-friendly 3-engine widebody than either the Boeing 747 or the DC-10. A jet that married long-range capability with new layers of avionics and redundancy. The program produced 250 airframes in total. The single most consequential technical choice was the engine.
The TriStar was designed around the Rolls-Royce RB210. The RB210 promised a high-bypass, triple-spool architecture and a lightweight, high-fill composite fan that would deliver competitive thrust and fuel burn. But the RB210 program hit catastrophic development problems, fan failures, weight and fuel consumption issues, and ballooning costs that drove Rolls-Royce into receivership in early 1971. The British government nationalized Rolls-Royce to save the program. Lockheed and the U.S. government then negotiated guarantees and revised contracts so the L-1011 could continue. Without that rescue, the TriStar as delivered would almost certainly not have entered service. The RB210 later matured, notably the -22 and later -524 series, and became a respected power plant, but the early crisis delayed deliveries and cost both companies heavily. Dimensionally and performance-wise, the TriStar sat between the DC-10 and the 747 in many measures. Common published figures for the main variants show length roughly 54.0 meters for the -1, wingspan about 47.2 meters, 155 feet, and maximum takeoff weights in the 995,000 kilograms or 430,000 pounds region for early models. Later -500 series increased fuel and range. Typical mixed-class seating ranged from 250 to 400, depending on fit, with maximum exit-limited loadings near 400 in high-density layouts. Fuel capacity, takeoff run, cruising speeds near Mach 0.84 to 0.85, and service ceilings above 41,000 feet all put it squarely in the long-range transport class. These raw numbers explain why airlines selected it for intercontinental trunk routes. What set the L-1011 apart was architecture. A highly redundant avionics and flight control suite designed for automatic landing capability. Lockheed integrated one of the earliest airliner systems designed for Cat 2 and 3 autoland operation with triple-channel autocontrol and flight director logic that supported hands-off approaches in low visibility. Direct Lift Control, DLC, a system that introduced small distributed lift changes via spoilers or ailerons to smooth and stabilize the flare, improved touchdown control, and was a marked handling advantage in marginal conditions. Those systems were novel for their day and gave the TriStar an operational edge in airports that emphasized low-visibility operations. Redundancy extended into hydraulics and electrical systems. The L-1011 used multiple hydraulic circuits with segregated routing and redundant power distribution paths so that a single failure would not remove critical flight control authority. The flight deck was a 3-crew layout, captain, first officer, and flight engineer, typical of the era, and the system's architecture placed many monitoring and management tasks with the flight engineer, while the automated flight controls reduced pilot workload on long sectors. Lockheed and its suppliers also paid attention to passenger economics. A wide fuselage cross-section, a 2-aisle cabin, flexible cargo decks, and large main deck doors for rapid turnaround. The TriStar attracted a diverse global operator base. Major flag carriers and charter operators worldwide bought the type. All Nippon Airways (ANA) and Trans World Airlines (TWA) were among the larger operators in Asia and North America. Saudi Arabian Airlines, Saudia, and others used it for Hajj and long-haul routes. Air Canada, TAP Portugal, and several European and regional carriers also flew the type. Militaries and governments later adapted some TriStar variants for transport and tanker rules, notably the Royal Air Force's TriStar tanker transport fleet. This broad operator list produced varied service patterns, scheduled long-haul, high-density pilgrimage flights, and cargo conversions, which in turn exposed the airframe to a wide range of operating environments. Lockheed's emphasis on systems paid dividends. Pilots commonly praise the TriStar for stable handling, good low-speed characteristics, and a forgiving autopilot in cruise. Maintenance crews valued the modular systems and accessible avionics bays, but the very complexity that made the TriStar advanced also raised certification, training, and maintenance demands. Autoland and DLC required operator training, RB210 maintenance demanded engine manufacturer support, and the triple-spool engines had different inspection regimes than rival turboshafts. Those trade-offs, advanced capability versus maintenance and operational overheads, shaped the TriStar's commercial life and eventually its economics compared with more fuel-efficient twin jets that emerged in the 1980s and 1990s.
After the Eastern Airlines crash in the Everglades on December 29, 1972, a tragedy that claimed 101 lives, the L-1011 fleet continued to operate without major incident for several years. The second catastrophic loss struck on 19 August 1980.
when Saudi Flight 163 and L-1011-200, registered HZAHK, departed Riyadh to Jeddah with 301 people aboard, 287 passengers and 14 crew. 7 minutes after takeoff, a C-3 cargo hold smoke alarm triggered. Captain Muhammad Ali Kawaiter declared an emergency and returned to Riyadh, landing safely at 21:06 local time. What followed became one of the most tragic procedural failures in aviation history. After touchdown, the crew rolled the aircraft to a stop on the runway, shut down all 3 Rolls-Royce engines, and waited for ground stairs instead of ordering an immediate evacuation. Thick, toxic smoke, fueled by insulation, carpeting, and cabin materials, spread through the cabin in minutes. By the time firefighters opened the doors, every occupant was already dead from inhalation and heat. All 301 fatalities occurred on the ground. The aircraft burned for hours, and investigators determined the fire likely began in or near the aft cargo area. It remains the deadliest L-1011 accident and one of the worst non-impact aviation disasters ever recorded. The next major loss came on 3 May 1986, not from mechanical failure or weather, but from terrorism. Air Lanka Flight 512 and L-1011-100, registered 4R-ULD, was parked at Colombia, Bandar Niki International Airport, being prepared for departure to Mali. While cargo was being loaded, an explosive device planted by LTTE militants detonated in the No. 3 aft cargo hold. The blast tore open frames and skin sections, caused structural collapse in the cabin floor, and ignited a fire. 21 people were killed and more than 40 injured. The aircraft, only 10 years old, was destroyed. Because the L-1011 had no inherent vulnerability to bombs beyond what any airliner would have, investigators attributed the loss entirely to sabotage. But it added another complete hull loss to the type's safety record. The mid-1980s also saw an accident that reshaped global weather avoidance training. On 2 August 1985, Delta Airlines Flight 195, an L-1011-1, registered N726DA, was arriving at Dallas-Fort Worth during a heavy thunderstorm. At 18:05 CDT, descending through roughly 800 feet, the aircraft encountered a microburst, a concentrated downdraft of more than 50 knots that produced a sudden tailwind and catastrophic loss of lift. The TriStar struck the ground short of the runway, hit a car on Highway 114, killing its driver, broke apart and exploded. Of the 163 people on board, 126 passengers and 8 crew died along with 1 person on the ground, totaling 137 fatalities. Investigators concluded no jetliner of the time, 747, DC-10, or L-1011, could have survived the microburst's vertical wind shear. The crash led directly to the adoption of Doppler radar, LLWAS wind shear detection, and new pilot guidelines for storm penetration. By the late 1990s, the L-1011's accident profile had shifted from high-energy impacts to ground explosions, wiring faults, fuel tank failures, and maintenance area fires, reflecting the fleet's age. Across its service life, the TriStar recorded 4 fatal in-flight accidents, several fatal ground accidents, and multiple non-fatal hull losses, but none of its major in-flight disasters were caused by structural or aerodynamic design flaws. The L-1011's engineering remained one of the strongest of its generation. Its accidents were shaped by weather, fire, sabotage, aging wiring, and human factors, rather than the kind of catastrophic mechanical failures that plagued some of its competitors.
By the late 1980s and into the 1990s, the Lockheed L-1011 TriStar's commercial career was showing signs of inevitable decline. Airlines were increasingly drawn to more fuel-efficient twin jets, like the Boeing 767, McDonnell Douglas DC-10 twins, and Airbus A310s, which could operate longer routes under ETOPS regulations without the fuel penalties inherent to 3-engine aircraft. The TriStar's Rolls-Royce RB211 engines, while technologically advanced and powerful, burned more fuel per seat than its twin-engine competitors, and the rising cost of fuel made operators reassess their fleets. The last scheduled passenger services gradually dwindled. Some L-1011s found new life in cargo and specialized roles. Notably, a few were modified for freight operations, although their three-engine design and older avionics limited their attractiveness to cargo carriers compared to DC-10 freighters.